Hey guys, in this video we're going to talk about configuring your flight controller board or your drone in Betaflight and get into a little bit more of the detailed settings for your drone. So let's go ahead and plug in our flight controller to Betaflight. If you guys have Auto Connect enabled, it should automatically select the correct COM port and just open up the settings for your drone in Betaflight. If you don't have Auto Connect selected, then you'll have to select the COM port manually and go ahead and click connect. Auto Connect usually works just fine, but if you're having problems connecting, you might want to deselect it and do it manually. So we'll go ahead and connect, get set up in here. For our purposes, we're going to go ahead and always enable expert mode. And actually up here in settings, we'll go ahead and click permanently enable expert mode. If you're following along with our videos, there really isn't anything in the expert mode that you can do that will ruin your drone. If there are any questions you have, if you're not sure what you're doing, go ahead and hold off and ask a question on our Facebook page or something like that before you do make changes that you're not sure about. Now that we've enabled expert mode, we're going to go ahead and go in here. We'll double check just to make sure first that our drone is oriented correctly. So I'm going to go ahead and face it away from me, hit reset Z-axis so that the camera is pointing the same direction as that green arrow, and just make sure that the drone is responding in the way that I expect when I move it around on my desk. And it looks like it is, so we'll go ahead and go to the next step. I'm going to go ahead and remove the battery strap so that the drone will lay flat on this surface. There are zip ties on the underside of the arms, which might lead to a slightly off-balanced drone or the flight controller not being completely level. But we'll go ahead and put this on a small cup to avoid those zip ties. And assuming this desk is level, we'll go ahead and look at the model in Betaflight and see if it looks level as well. It looks like it's slightly off, so I'm going to go ahead and hit calibrate accelerometer. Once that's done calibrating, it should be level and you should be good to go. If you're not sure if your table is level, go ahead and use just a level, or there are apps on your phone you can download to make sure that it is level before you calibrate your accelerometer to a table that's not flat, for example. Oh, and you'll notice right here that none of this information seems to be quite right. That's because we haven't plugged in our battery, so we're not getting a lot of detailed information yet, and that's just fine for now. So we'll go ahead and go into our ports tab. This tab is probably the most important tab to have configured correctly, and that's because if you haven't told your flight controller where your receiver is or where your video transmitter is, you'll run into a lot of problems later and get a lot of grief. And that being said, if you are running into problems at a later point in this video, a later stage in configuring your flight controller, and you're running into problems, I would check the ports tab first and make sure everything is really correct here. So the first thing you'll want to make sure is right is the serial RX. This refers to the UART, or the pad, the transmitting and receiving pad that you set up your receiver on. And that's the most important one. So for this build, it's on UART 2. And we know that because we assembled the drone and we put the receiver UART on UART 2 for the flight controller. There are other options. You can set up telemetry, so you get data for your drone's battery or other things like GPS coordinates to your controller. We won't be setting that up for this drone. All of that information will be sent to your OSD or your on-screen display in your goggles. The next thing we'll need to set up is the smart audio, which is the way to control your VTX settings through your controller and using the settings menu in your on-screen display. So in order to do that, we set up our camera control on UART 5. So down here in peripherals, we'll go ahead and select VTX TBS Smart Audio. There is another protocol for smart audio or controlling your VTX through your goggles called TRAMP, but that's only for specific VTXs. For most part, you'll use smart audio. So we'll go ahead and enable that. In sensor inputs, there are other things like GPS or ESC data, but for our drone, that's all we'll need to do. We'll set up the serial RX on UART 2, the smart audio on UART 5, and go ahead and hit save and reboot. So we'll it'll essentially close out the whole settings and then open it back up. And once we go in here and we'll double check that this still says VTX Smart Audio, we know we're good to go. So next we're going to move on to the configuration tab. So there's a couple things you'll want to look at here, but we'll just kind of work our way down through all these settings and make sure you have an understanding of them. The first thing is the drone style. Ours is a quad X. That just means that it's an X shape and we got 4 motors. There's a lot of different things you can do in here. Hexcopters, octocopters, wings, but we're just going to use quad X. For most drones, In fact, I'd say up to 90% of the drones you'll encounter, the motor orientation, the motor rotation will be as follows, where these two motors are going in towards the camera and the back two motors are going in towards usually where the VTX antenna is. If that's not the case for your drone, you'll go ahead and select motor direction is reversed and save and reboot, but for ours this was correct. The next thing you're going to want to look at is the ESC or motor features. It looks like for the default setting for the flight controller target that we flashed was brushed, but we'll go ahead and move that to DShot 600 for this drone. The motor protocol or the ESC protocol is going to be dependent on your ESCs. So if you're building a drone that's not the Hawk Pro, you'll want to make sure and look at the ESC you've selected and what protocol it supports. So we use DShot 600 and we can leave pretty much everything else the same. We don't need to worry about any of these other sections for right now. So we'll just make sure that the DShot 600 is enabled. Next, we're going to go ahead and go down into system configuration. These two settings right here, you won't need to change them hardly at all. Usually stock will be just fine. They're essentially how quickly the drone takes data from your ESC or what your motors are doing and sends it to your flight controller. If you have it too high, it can overwhelm your flight controller. If you have it too low, you can have a sloppy flight performance. We also have accelerometer and barometer and magnetometer. The two previous ones, barometer and magnetometer, aren't even on this flight controller board, so I'm going to go ahead and deselect them. Barometer tells you air pressure and can give you altitude readings, and magnetometer is like a GPS, it gives you a heading. But we only really need accelerometer for balanced flight or stabilized flight. So that's good to go here in system configuration. We don't need to change anything in board and sensor alignment or accelerometer trim. In arming, what we're going to do is we're going to go ahead and turn the maximum arm angle up all the way to the highest possible value, which should be 180 degrees. Now, a little warning that comes along with doing this. The reason that the maximum arm angle is usually down is so that if you're holding your drone at a weird angle and accidentally arm it, it doesn't chop your fingers off. But in order to use crash flip, which is where if your drone flips upside down, you can flip it over, or turtle mode, you do need to have the maximum arm angle turned up to at least 180. So we'll go ahead and do that, but keep in mind that if you have your maximum arm angle up to 180 and you accidentally arm, the motors will arm, and if the props are on, you could cut your fingers, which I have personally done, and you do not want to do that. Craft name, that's totally up to you. You can set this up however you want. We'll go ahead and put FPV unlocked for ours. FPV camera angle, you can go ahead and leave the same. It doesn't really have a huge effect on your drone. For the receiver settings, the serial-based receiver and S-Bus is what we are using here. In some scenarios, you use FrSky F-port, or if you're using a Spectrum receiver, you might need to change these settings, but typically serial-based receiver and S-Bus will be the standard. That's industry standard right now. For these settings over here, you won't likely run into these unless you're flying with a GPS for long-range builds or a 3D drone, which can actually fly upside down as 45-degree pitch motors. Pretty cool, but not something that we're going to cover today. Other features that we'll look at, this stock will usually be pretty much what you want. Telemetry output, we can go ahead and deselect. We're not going to be getting telemetry information to our controller. We're going to be using our on-screen display, our goggles, to do that. Everything else looks like it's good to go. Permanently enabling air mode means that the standard for your drone is acro mode. We'll go ahead and leave that on for now, and we'll set up flight modes in the controller so that if you want to fly and stabilized, you can. On-screen display is enabled. Anti-gravity and dynamic filter are tuning settings that will help the quad fly differently. We'll go ahead and leave those on. Those should help with your flight characteristics. DShot beacon configuration. This is something we'll go ahead and enable for RX Lost. Since we don't have a buzzer on this build, the ESC can work in the case that we lose our drone, it gets lost in the field and doesn't have a connection to the controller, it'll start beeping. So it won't be as loud as a standard buzzer, but it will help if we were to lose it in, let's say, tall grass or something. So go ahead and enable that. And then beeper configuration. These are all configured right now. You don't need to use all of them. It's kind of personal preference. If you leave them all on, it'll beep at you a lot, which can be helpful sometimes. I like to select certain things that are meaningful to me. I'll leave gyro calibration enabled because that's helpful to know once your drone is ready to go. When you plug in your drone, it'll go through a little setup and it has to calibrate the gyro before it'll take off. So if you try to arm it before that's done, it won't arm. So you wait for the beep to happen and then you can go ahead and arm. RX loss, that's good. RX loss landing, we'll go ahead and deselect that, as well as disarming. Arming we'll leave on. GPS, we're not using a GPS. Battery crit low, that is good. So when the battery gets very low, it'll beep at you. GPS, again, we're not using. We don't need the RX set. We don't need in-flight calibration, so we'll go ahead and select those. GPS lock, again, we're not using a GPS. Disarm repeat. So I'm going to go ahead and set these as I would have them. If you're curious about why I did any of them, go ahead and read these. And this won't change any major flight characteristics on your drone. So if you think you want that beep enabled, go ahead and go for it. Now that I have the beeper configured like I want it, the other features enabled and everything, I'll go ahead and save and reboot. And once that's connected again, I'm going to go back into configuration tab and just double check a couple of them that I know I changed, like the arming angle, to make sure it really worked, and saved all those settings. So it looks good. So we'll move on to the next one. Power and battery, we're not going to go over this right now. There is ways to get the current output in your goggles. That's something that's an advanced feature that you won't need right away, but the voltage output should be configured for you already. In the fail-safe settings, we're going to decide what happens to our drone if it loses battery, it loses enough battery life that it's too low, or if it loses connection to your controller, what it's going to do. So there's a couple different options. Right here you see the main options. There's drop, land, and return to home. The final two, GPS rescue, is only really possible if you have a GPS setup. So we don't have a GPS, so that's not really an option for this build. Landing, that's something that has been configured that the drone could land itself, but because it doesn't really have a heading from where it came from, it's not advisable to use the land failsafe. Drop is pretty much the standard. Quadcopters are built to handle hard hits and to be very durable. Usually the safest option is just to hit drop. If the drone isn't in your control anymore, you don't want it flying somewhere that you don't have control over. You don't want it to fly into someone's house, and you shouldn't be flying it over people in the first place. So if it just drops, it should just drop wherever you were flying it, and you should be good to go with only minor damages. So we'll go ahead and leave drop as the failsafe, and in that case, we don't really need to configure anything else in this tab. The next tab that you'll see is PID tuning. PID tuning is essentially changing the characteristics of your drone's flight ability. So sometimes drones will have strange bobbles or oscillations, and you'll want to address those, and that will be done here in the PID tuning settings. We won't go over them in detail right now. There is going to be future videos that will talk about them in a lot more detail. But a couple things to mention: you can set multiple profiles so that from your goggles you can quickly change between different flight characteristics. You can also change rate profiles. And really quick, a note to make towards PID tuning: there are these PID settings, proportional integral derivative for roll, pitch, and yaw, which change the flight characteristics. And then there's also rate profiles, which change the input from your controller. So that's why there's a rate profile and a PID profile. PID profile refers to these values here. Rate profile refers to these values relating to your controller inputs. Next tab we're going to go to is the receiver. So at this point, we're going to go ahead and bind our drone to our receiver. In order to bind your drone, it will need to be powered by a battery. Some flight controllers will power the receiver from a USB, but in a lot of cases, and in our case, it needs a battery in order to power the receiver. So I'll go ahead and put the controller in bind mode, and you'll know it's in bind mode because of the annoying chirps. And then, holding down the bind button on the receiver, I will go ahead and power on the drone with the battery. A note: make sure your props are off for this. You're likely going to have to hold the drone at a weird angle in order to hold the bind button and power it on, and you don't want that to power up. Now we've bound, I'll go ahead and exit the binding procedure and unplug and plug it back in. Now we just saw that a couple of these settings just changed, so we know it worked. And we'll go ahead and test that by lifting up the throttle, and throttle goes up. And let's go ahead and move yaw. Oh, and so we'll notice right here, I changed the yaw input. The roll slider changed, so we'll have to fix that. Let's go ahead and try pitch. If I do pitch, it looks like that's right. If I do roll, it looks like it's on yaw. There's the calibration beep that we set up earlier. So since we have our yaw and our roll is mixed up on our sticks, let's go ahead and try making sure we're on the correct FrSky setting here for the channel map. And let's save that and refresh and see if that fixes what we had. Nope, looks like it's still the same. Let's try that again. Sometimes I've also found just changing it from default to spectrum. As long as the inputs are correct when you move your sticks on your controller, we should be good to go. So for some reason, it looks like it didn't keep to the new channel map. Now I'll mention TAER. That's referring to throttle, aileron, elevator, and rudder, which are actually airplane terms. If you're getting confused by those, you can look right over here and you'll see those. R or rudder refers to yaw, E or elevator refers to pitch, and A or aileron refers to roll. So let's go ahead and try with this other setup. And now our pitch is throttle. So that's further away from what we want. So when we were working in the receivers tab in Betaflight, we noticed that the rudder and the aileron, or the yaw and the roll, were switched. So we need to swap these in our transmitter to get them to correspond to the correct inputs in Betaflight. So all I'm going to do is I'm going to go in here to inputs. I'm going to hold it down and click edit, and I'm going to change rudder. I'm going to change it to aileron because we're needing to switch it with aileron, which is AIL. So I'm just naming it. This doesn't actually change anything besides the name in the controller for your reference. And I'll go down here to source, and I'll change from rudder to aileron. And I'll back out, and we're going to do the same thing, but now we're going to change aileron to rudder. So hold down the silver button, click edit, and I'll go ahead and change it to RUD for rudder, and change the source, scroll up to rudder. So now we've swapped aileron and rudder, these two motions. So now in Betaflight, it should show yaw here and roll here. And we also need to do actually the same thing on the mixes page, which is just one page over. We'll hold it down, change this source to rudder, back out, and change rudder, hold down, edit, change that to aileron. So now we have rudder and aileron changed. We should be good to go. And you can go ahead and change those mixes settings until it looks all right. Throttle being on your left hand with the up and down motion, yaw also on the left hand with the side to side motion, pitch right hand up and down, roll right hand side to side. And so now we're seeing what we want to see, and we should be good to go on to the next section. We'll go ahead and save our progress to make sure we have everything saved how we had it. I'll go ahead and disconnect the battery at this point. VTXs, or video transmitters, will get hot if they're sitting still, plugged in, and there's no airflow. So it can ruin the video transmitter if you leave it plugged in without flying it for too long. So that'll do it for this section on Betaflight configurator settings for your drone. And if you have any questions, again, feel free to let us know, and have fun flying.